Okay. Like I said, we have what I'll call, as close as we can get to a quorum. We have a sufficient number of us in this class, so we can proceed. Now, as from next week, Thursday, 6:20 p.m. to 7:35 p.m., we will hold a normal class, like a classroom. Now, the difference is that I will be on campus and delivering the lecture, and you are going to see it as a regular classroom. You don't have to be on campus. But you will be able to watch the lecture, and you will see me on the screen. I will see you if you're participating. You will receive all the links that enable us to be able to see each other. And so you would, record the lectures and you can watch them over again. All right. Now, for today, what we're going to do is we're going to go through the basic concepts, and then we're going to look at the discussion. If you would like to modify your discussion, just let me know. If you've already participated. If you have not, please try to participate. And after you participate, or after you submit your comment, please comment on at least one of the students in the class for you to receive full credit. And I'm going to modify the discussion forums to reflect just that. Now, the homework assignments, I see that I still don't have any participation. Please try to complete the homework assignments. It's very essential that you complete the assignments. And so I'm going to go through them today. And then the quizzes, there's going to be a quiz every week. So please complete all the quizzes. And you can do the quizzes as many times as you need in order to improve your performance. The syllabus says there's going to be a required paper. I'm going to delete that. We don't have the facilities yet to be requiring a paper for this class. It used to be that we required a paper, but I'm going to delete that requirement. So we will have a midterm exam and a final exam. The midterm exam is going to be written. It's not going to be multiple choice. You're going to have to solve problems throughout in the midterm exam. So having said that, let me pull up the basic concept we're going to be talking about today. And then we will then proceed to have a conversation about the discussion forum, and also have a conversation about the homework assignment. Okay, so just give me 1 minute and we will get to it. All right, so let's begin. This class is going to be about applied statistics. Okay, applied statistics. Now, let me just define statistical analysis for us to bear in mind. And I still use the very first definition of statistics or statistical analysis that I heard on the very first day I went into a business school. Essentially, what statistical analysis does is that It's the collection, organizing, and analysis of unorganized mass data. Okay, the collection and analysis of unorganized mass data. That is what essentially we are doing. Now, having said that, for this particular class, this is the second level statistics class. It's an intermediate level class. So we are going to focus on applied statistics. This is number one. Number two, the emphasis will be on, and I'm going to share my screen now. There are two kinds of statistical analysis, okay? The first is what we call descriptive statistics, okay? It's simply a method for organizing and summarizing data in an informative way, in the sense that, for example, what is the average cost of beef in the neighborhood? What is the average age of students in a class? What is the average income of doctors? What is the average income of a neighborhood, and so forth? So it's a simple summary, and that describes the characteristics of a subject. And I said it's characteristics of a subject. What is a subject? The subject could be houses in a neighborhood, and the characteristic could be the average size of living space of houses in this neighborhood is 1,300 square feet, compared to the average size of houses in another neighborhood, which is 900 square feet. So here you have provided a comparative description of the two neighborhoods. But that does not really mean too much, because a lot of information could still be identified, or could still be, obtained from the available data. The other branch of statistics, and there are two of them, excuse me, is inferential statistics. And inferential statistics essentially is where we use information from a sample to make decisions about a population, or to reach conclusions about a population. Now, at this point, we have to then differentiate. We have to differentiate between the sample and a population, and also ask ourselves the question, why do we use a sample in statistics instead of looking at a population? Let us, explain population in a practical way. Think about, say, students at Medgar Evers College. Now, if you were able to identify every single student that is registered at Medgar Evers College, that will be your population. Now, suppose you wanted to ask yourself, what is the average age of students at Medgar Evers College? If you are able to get every single student who is registered and using the available record to calculate an average age, then you have what we call the population parameter, or the population average of their age, which is the true population average. And we call it the true population average, or the true population parameter, for the simple reason that there is no other average that you can get. Since everybody has been counted and everybody has been measured, every member of the population has been measured. And so any average that you get is the true average. Now, Suppose, however, that you don't have access to that record. And suppose that you just wanted to make a quick decision about the average age. Then you can take a sample of, say, 30 students or 40 or 50 students that you see in a classroom and obtain a measurement of their age. Then that is a sample. And if you obtain an average of their age, of whatever you want, of their height, of their weight, of their income, or their average travel time from that sample, what you have is called a sample mean, okay, a sample average. And in inferential statistics, we use information from a sample to make judgments or to reach conclusions about the population, which is to say, if you take a sample of 50 students and measure their average income, then you can say that the average income of students at Megavast College is about, say, $15,000. It's about $25,000. It's about $30,000. You use the word about for the simple reason that you don't have the true value. The true value can only come when you have the entire population. But if you have a sample, all you have is a sample calculation. And so you use information from that sample to estimate what the population looks like, okay? And so why do we rely on sample? We rely on sample for the simple reason that sometimes the population cannot be accurately measured. You don't have information to the true population, okay? Sometimes trying to get the true population, even if you can, is very costly. When I say it's very costly, now what if you wanted to actually count every person in Brooklyn and every household in Brooklyn? That will take a lot of time. Secondly, can you truly measure the true population of Brooklyn? Can you truly measure the true population of fish in a fish pond? You cannot, because fish go in and out of the pond, but the fish that stay in a particular pond would have a characteristic that can be measured, the average weight of fish in that pond, because only fish of certain kinds come to that pond. All right, so that is why we said we use sample to make inferences about the population. So now, having said that, I'm going to move on to the next phase, because we are supposed to have done this in statistics 1, okay? Now, for this class, we're going to mostly use what we'll call ratio level data. There are 4 levels of measurement in statistics, okay? There's nominal level, there is the ordinal level, then there is the interval, then there is the ratio. We're going to use mostly ratio data, but we also are going to apply ratio data against nominal or interval, okay? We might use ordinal kinds of, we might use interval data, but we're going to apply ratio against nominal and ordinal. All right, so let's then move on to the next level, which I believe many of us are already familiar with. And then I will go and discuss the discussion. I'll review the discussion and also review the homework assignment, okay? Again, So okay, so now one of the things that we do in statistics, we have different kinds of measures in statistics. We're going to focus in this class on calculation of the mean, and which we call a measure of location. We're going to be measuring the population mean, and then we're going to be dealing with the sample mean. We're going to use information from the sample mean, to make judgments about the population mean. Okay, and so you can see the examples of how to calculate the mean. Okay, for example, if you have data, let me just pull up a sample of data, which is the population mean is the summation of the values. And so let me pull up some values, and okay, suppose we have, say, values called x. Okay, and we have the x value, and so let us say that we're looking at age. Okay, so we have values 4, 3. And so we ask ourselves, what is the average of these values? The average is simply, as you can see, you have there are 6 observations. And so the average will be to add the all the values here. And so it's very simple. You can use the auto sum here.
Professor, are you sharing something else? Because all we're seeing is the PowerPoint.
Oh, sorry.
Yeah, another thing is like you have to stop sharing, then go back to share.
Yeah, yes.
So yeah.
Okay, sorry.
No problem.
And thank you so much for bringing this up. Okay. So I'm going to share what I'm doing here. Okay. Suppose you have say, some variable called x, and which say is the age of children in a room. Okay. And the ages are 4, 3, 5, 7, 10, and 11. Okay. So you have 6 children in the room. And so the average will be 40 divided by 6. Okay. Because here you have the sum. Okay. And the average is 40 divided by 6. And so the average age is 6.667. Now you can easily do this with Excel. So I'm going to copy those values again. With Excel, you can use the auto sum average here. And so you get the same value. So this is average. And we're going to exemplify the homework assignment in this way. Okay. So we're going to calculate averages. I just stop the screen share. We're going to calculate averages. We're going to calculate standard deviations. We're going to use them to make inferences. So, and I'm moving through this quickly because I know we have covered this in the past. So I'm not going to spend time on it. My suggestion is please review the PowerPoint slides and then try to practice But again, I'm going to take you through some practice here to make it easy, because at this second level, the emphasis is on practice. So this is what we're going to do. But please review the PowerPoint slides, because I'm going to assume that you have reviewed them, and I'm going to evaluate you based on what you understand. So this is what we're going to do in this class. It's mostly inferential statistics. So next week's lecture, I'm going to truly introduce inferential statistics. But today, we're going to do two things. We're going to lay the foundations for descriptive statistics by calculating means, by calculating standard deviations. And let me see. Okay. We're not going to spend so much time on means, but we're going to look at weighted means. Okay, let me use this opportunity to look at weighted means, because you may have to calculate weighted means. Now, a weighted mean is simply the same thing as a mean, except that certain values are more frequent. So I'm going to give you an example of a weighted mean. So I'll stop sharing here and pull up . All right, suppose you have another value here called y, okay? And y, again, is age. Okay, and suppose you have the ages ranged from, say, 8, and you have 9, 11, 10, 12, 15. Okay, but suppose you are in a location where, or suppose you have data where you have, of course, age and then frequency. Suppose there are 10 people there who are 8 years, and suppose there are 12 who are 9 years. Suppose there are 15 who are 11 years. Suppose there are 7 who are 10 years. Suppose there are 4 who are 12 years. And suppose there are 2 who are 15 years. So you can calculate what is called a weighted mean. And a weighted mean simply means that and the frequency here is what will be the weight. Okay, so here you multiply the weight times the variable value, W times Y. So this is weight times value. That's what you do. Okay. And so here you have H16, you can see, times I16. So you multiply the weight times the value, and you simply drag it down. And so you get a sum. You sum all of that. And so the average will be the sum of the values of the weight times the values by the total frequency here. So there are 50. And so the average, the mean will be equals H22, sorry, J22 divided by I22. Okay, the sum divided by the total frequencies, which is the number of people there. So the average is 10.02. All right, you might have to do quite a bit of that. I'm going to stop share. And so having said that, and we're also going to do like weighted standard deviation, but I suggest you practice on that. If you have issues, please give me a call or send me an email, and I can do a Zoom session to clarify things for you. So I'm going to now go to use the homework assignment as an illustration. Okay, let us look through the homework assignment. As a matter of fact, I'm going to ask you, would you prefer to review the homework assignment or would you prefer to look at the discussion? Because the discussion is where I need for us to discuss the process of statistical analysis. Okay, fine. Let me go to the discussion first. We'll go through that very quickly so that you can post your responses, and then we'll go to the homework assignment. Okay, you see my screen? Yes. Hello?
Yeah.
Okay, please, I need to, I would like to get responses when I ask the question. All right, so this is a typical example in statistical analysis. And I bring this up because we are at this level, this intermediate level. Okay, let's look at the steps in statistical analysis, look at how to answer a question in statistical analysis. Now, here we are talking about a real estate company, okay? And the managers would like to explain whether there are differences in the prices of houses in two locations. So you have two locations here. One is called Eastville, and the other is called Apple Valley, okay? And Jack and Jill, two people in the company, have explained to their manager, Mr. Pelowata, that any differences in the prices of houses in the two districts can be explained by buyers' preferences, which is to say that the difference in the prices has nothing to do with houses being better in one district than another, okay? But the manager feels, though, that the differences in house prices can be explained by differences in the average age or in the average sizes of the houses, because houses in one district are typically bigger than houses in the other district. Therefore, that means that the houses that are bigger are going to be more costly, or the houses that are older or the houses that are newer will be more costly. Now, we don't know, okay? Now, this is the kind of question that statistical analysis can help you to answer. And we will use inferential statistics as once we begin to learn how to do inferential statistics to answer questions like this. So my question to you, and I would like for you all to participate. I want somebody to give me an answer. How would you approach this question? You have information here, okay? What are the questions that you will answer, and how will you approach the question? Okay, I would like Charlene Jackman. Do you
Yeah.
have an idea how you would approach the question? The
Yeah.
questions that should be answered in order to resolve the issues raised.
A few questions. I think I would look to see what the mean size of the house is,
Okay.
and then the square, what the square feet of the house is compared to the price, and then I'll be able to ask, like, does the house price vary on the basis of the buyer's preference from Apple Valley over Eastville School District?
Okay, what would be buyer's preference? David, could you give us an idea of what the buyer's preference could be?
Let me see. I think the buyer's preference would be the probably would it be the combination, the average of both prices? Would it be the average or combination of both prices?
No. Okay, let us say that you see what when somebody says that the difference in prices is based strictly on buyer's preferences, which means that the difference in prices has nothing to do with the size of the difference in size of houses. So what will be such preferences that will make you as a buyer to overlook the price differences?
Oh, so if it's completely like structural, could be maybe the size of the house, the area the house is located in.
Okay, that's one.
Uh,
Why would you prefer Apple Valley to Eastville? And just ignore price and say, I don't even want to look in Eastville. I'm just going to look in Apple Valley.
Oh, maybe Apple Valley has a better maybe it has a better school system.
Okay, that's the one.
Maybe it has more resources, like maybe like if you have a family, you have playgrounds for children and more after school programs.
Okay.
And stuff like that. Yep.
Yeah, okay. So this is what we're talking about. Okay. Let us say that I prefer Apple Valley. I'm not even going to look at Eastville, right? And so I go to Apple Valley and somebody shows me a house that's 2,000 square feet. And they say it's $400,000. And then somebody comes and tells me, but I see another house in Eastville that is $350,000. You're going to save $50,000. And that house is also 2,000 square feet. So I don't want it. You can keep the $50,000. And your reasoning makes sense. Could be they have better facilities, the neighborhoods could be safer, they have better schools, whatever it is, okay? Or they have, people of certain income, and so you want to belong there. So this is what we're talking about, pure preference. Pure preference simply means I'm going to overlook the price difference. Okay. But now the question then, how would you approach doing such an analysis? To ask yourself, are the difference, is the difference in prices due to pure preference, or is it because prices are different? Or is it because the houses are older? For example, there are places where older houses have better structures. There are places where newer houses have more facilities, okay? And so you say to yourself, I will buy in Apple Valley, even though the houses are older, they have less facilities. I will buy a house in Apple Valley that costs me $50,000 more, and I'm going to put another $30,000 to improve the facilities. So that is pure preference, all right? So how would you, but these two people that are advising the manager want to explain. They want to explain that the difference in house prices is due to plot preference, or it is because houses on one side are either bigger or they are older, or even because they are newer. How would you then approach statistically to find out if that is the case, or to find out which is the answer? How would you approach that in statistical analysis? What would be your first step? What would be your first question? When you look at the data, what would be your first question? So Christina, do you have an idea?
Would it be, does the house price vary on whether the location is in Apple Valley School District or in Eastville School
That is
District?
the question. That is the question. How would you answer it? Let me help, okay? Because this is why I want to give this lecture, so that you can understand how to do statistical analysis. The first step, the first question that you will try to answer is, are the prices in these two neighborhoods truly different? That is the first question. Because nobody knows that. The three people that are involved in this discussion do not know, they are not certain that the prices in the two neighborhoods are really different. They are not certain. They're simply saying, if there's a difference in the prices, then it is because. So your first step is to find out if the prices, if the average price of houses in the neighborhood, the two neighborhoods, are truly different. What if the prices, the average prices in the two neighborhoods are not truly different? What is your next step? Yes, David. What if you now go and do a test? We are not getting to the point where we're doing a test yet, but what if you go and do a test and go and calculate the averages, and the average prices of houses are not different? What would be your next step?
So if they're not different, if the averages aren't different, then if everything's the same, like let's say like the average of the price of the house, because we're not taking prices into consideration, I would say probably the next step would be maybe the size of the house, the number of bedrooms in the house, or how old the house is. I would probably look at that. If the average price is on the same.
Let me answer the question for you. If you go in and calculate the average price of house in neighborhood 1 and average price of house in neighborhood 2, and they are not different, they are about the same thing, the rest of the argument is moot. The rest of the argument is moot, because you are saying, first of all, that there's a difference in the average, and that the difference in the average is because of some reason. Then you step in, calculate the averages. The averages are the same. So the other questions are moot. They're irrelevant.
Okay.
Because you are saying that there's a difference in price, and the difference in price is because, but when you go out and measure the two averages, they are the same. So you have no need to be answering the other questions. You have no need to be answering the other questions.
I see.
Because then that means that the preferences, if there's any preference for one or the other, it's just a pure, a pure preference. You're simply saying, okay, I mean, if somebody buys here or there, it's because they prefer this place or that place. Okay, so, but now if you go in and then find out that there is truly a difference, that the average price in one neighborhood is higher than the average price in the other neighborhood. Then you move to the next step. Then you want to find out what is the problem. Is it because the prices in this higher cost neighborhood is higher? I mean, is it because the sizes of houses are bigger? Or is it because they're older? Or is it because they're younger? They are newer houses. All right? Okay. So that is what I would like for you then to answer, and then explain the procedural process, and then answer the questions, the other questions. And I want you to bring out the questions of why would somebody have a pure preference. Okay, so having answered that, let's now go and try to brave the homework assignments. All right. I'm going to, you still see my screen?
Yes, I see the screen.
All right, so let's try to look at the homework assignment. I'm going to do a part of it. So what are you seeing on the screen? You're seeing
we see quiz intro 1,
okay.
quiz 1 intro assigned.
Okay, so now you see where it says that you have data on housing, and I say use the Excel command to calculate the average age of houses in each neighborhood. All right. Okay. And so you can answer the other questions after you calculate the averages. So let me give you an idea then how you should proceed. Are you seeing the Excel coming up?
No.
Okay, so I'm going to stop share. I'm going to stop share, and then we will pull up the new file. All right, so what are you seeing now?
Okay, yeah, now I see the
Okay.
spreadsheet.
So we are going to calculate the average price there are 3 neighborhoods here, right? There are 3 neighborhoods. So you have the variables. The variables are price, sold date, house square feet. House square feet is the amount of living space in the house. LT square feet, the lot square feet, is the size of the land in which the house is built. Year built is the year in which the house was built. Price per square foot is the total price divided by the house square feet. And NEB represents the neighborhood. Okay, there are 3 neighborhoods. And so the neighborhoods are Harbor, and that is neighborhood 1. Westcott is neighborhood 2, and Westlair is neighborhood 3. Okay, and that is explained. So you ask yourself, we were asked to calculate the average age of the houses. Okay, the average age of the houses. So how would you calculate the average age of a house? Can somebody tell me?
I mean, what I think I could do was first is find the difference between current year and the year it was built.
Okay,
and then
that's it. The year it was sold minus the year it was built. And so you come in here and you create that variable age. You can see I did not give you age. I wanted you to calculate it yourself.
Mhm.
Okay, equals B2 minus E2. Get it?
Yep.
So the age of that first house you see there is 69. Make sense?
Yep.
And
Right.
so you go
Autofill.
down. And so now you have the age of each house. You get it?
Yes.
Now you have the age of each house. So the next thing that you do is to sort the data by neighborhood. You can see the codes are there. Okay, if the neighborhood is coded 3, it's in West Layer. If the neighborhood is coded 2, it's in Westcott. If the neighborhood is coded 1, it's in Harbor, right? So we sort the data. And you go to data. You go to sort. You sort by neighborhood because you want to use neighborhood. You want to put all houses in one neighborhood in one area. So you can see that all the houses in neighborhood 1, Harbor, are out there. All the houses in neighborhood 2 come next, and all the houses in neighborhood 3 come next. All right. This may not be the way I defined this in your assignment, so please don't just copy this and take it away. Look at my own designations in the assignment itself, and then use that as the way you solve the problem, because I'm going to solve it correct, and I'm going to judge you by the correct solution, not by what I have here. All right. So, and I also want to see your spreadsheet. I just don't want to see answers. I want to see your spreadsheet. So now that you have the houses identified according to neighborhood, you can now write down information that you need. So neighborhood 1 goes from row 2 to row 39. Okay. Neighborhood 2 goes from row 40 to row 61. And row 3 goes from row 62 to row 92. All right. All right. So now you can calculate average. Okay. So you calculate the average. You have Harbor of Westcott, West Layer. What I'm going to do, I'm going to calculate average, average age, so that somebody knows what I'm doing. Average age. And so I'm going to say equals average H2 colon H39, close it, And so the average age of houses in Harbor is 60.28 based on 60.29 and so the next one will be average will be H40 to H61. I see how I'm making life easy for myself. Okay, the average has the average age of houses in Westcott is 58.82, and we have 62 to 92, and the average age of houses in West Layer is 53. Okay, now doing something a little bit more fancy, which is to put borders around it, and you can cut, copy, okay, and paste this on MS Word. Okay, this is what I want to see you do. You paste it on MS Word, and you can put a chart, or you can just leave the table and label it. So did you see everything that I was doing?
Yes.
Okay.
Yeah.
Okay, does anybody have any questions?
Professor, did you open up a Word document, or you're just saying to do it on Word document?
Yeah, you can you see the way I painted it, you can copy it and paste it on the Word document.
Oh, because I don't see the Word document, I still see your spreadsheet.
I
But
know, I
it's-
did not open the Word document.
Oh, okay, yeah, that's what I was asking, if you open a Word document.
No, I did not.
Oh, okay.
I'm just saying that's what you should do.
And you still want to see the Excel spreadsheet.
I
So
still want to see the Excel spreadsheet. You're gonna have to upload two files, the Excel
Okay.
file and the MS Word file.
Professor, do you need a written explanation as to like the formulas or anything like that?
No.
or-
I just when I look at your Excel spreadsheet, I'm gonna see that formula there. You see the formula up there?
Yes.
You see where
Yes.
the average is there?
Yeah, I
I'm
see
gonna
it.
see that. When I look at your spreadsheet, I'm gonna see you do the calculation here. I'm gonna see what you did. So I don't want you to do it by hand, one by one. I want you to use the Excel spreadsheet because that is where you actually practice how to do statistics in this day and age.
Okay.
All right?
Okay.
All right. Any other questions? All right. In the absence of any other questions, I'm going to close class, and I wish you all a nice evening.
thank you.
Oh, Professor, actually, I have a question, but it's not related to the lesson. I had a question regarding to the structure of the class. So next week, which is the 9th,
Okay.
we will be meeting at 6:20
Yes, on Thursday.
on Thursday. Okay.
And every Thursday. And I will be in class to give a lecture on the advanced subjects we're going to be doing, and also to be reviewing the homework assignment and giving you guidance on how to approach the assignments.
Okay.
All right.
And in the event that if anyone can't make the class that day, can
you will see the recording.
See the recording. Okay.
And yeah, it will be broadcast. It will be broadcast live, so you can participate in it. You're going to be seeing me like you were in the classroom with me.
Okay.
It's not just, you're not going to be seeing only the PowerPoint. You're going to be seeing me. And if there's any student that decide to attend class that day, you're going to be seeing that student too.
Okay.
It's going to be like you were in the class with other students. Like I said, you don't have to attend. but I will definitely be there. There's nothing like I may. And I don't need anybody to be inside the classroom with me. I take it that somebody has to be watching. So I'm going to give you the Zoom link so that you can all log in on Zoom.
Okay, so somebody has to be watching in order for you to be, so you'll be doing it regardless whether, because like if I have to, like if one day I can't be there to participate, I
I
won't
will
get
do it
penalized.
regardless, even if you're not participating synchronously online. I'll
Okay.
deliver the lecture as if there's 1,000 people in the classroom with me.
Okay, so but I won't get penalized for
No.
if I'm okay.
No, you will
Okay.
not get penalized.
Okay, thank you.
All right. All right, so that does it for the evening. And hopefully I'll see as many of you as possible on Thursday evening.
Okay, great. Thank you
All
very
right.
much, Professor.
Good
Thank
night.
you.
Have
Good
a great
night.
weekend.